Hi students, in the last lecture we had discussed about the Kirchoff's voltage law and KCL. Today we are going to discuss some more problems on the same topic. Okay, the question is that a Wheatstone's bridge ABCD, it is arranged as follows. AB is equal to, AB is this branch, AB is equal to 1 ohm, BC is equal to 2 ohm, CD is equal to 3 ohm and DA is equal to 4 ohm. A resistance of 5 ohm is connected between the terminals B and D. A 4-volt battery of internal resistance of 1 ohm is connected between A and C. This is A and this is C. It is connected between A and C, and calculate the magnitude and direction of the current in 5 ohm resistor. And second one is that the resistance between A and C. What is the resistance between these two terminals? Okay, A and C. So the figure shows a Wheatstone's bridge ABCD, and we have to mark the various currents in the various branches of this Wheatstone's bridge, and we can mark it as A to B. The current which is flowing from A to B is I1, and A to D is I2, and the current which is flowing through BD section is I3. So on the basis of this three currents, we can find out the other currents. That is, at the point B, the I1 is the current which is entering at point B, and the I3 is the current which is leaving from the point B. So the current which is flowing through this section is I1 minus I3. And here the current which is entering at D is I2, and this current is also entering at the junction D. So the current which is flowing through DC section is I2 plus I3. So at point C, I1 minus I3 and I2 plus I3 is entering here. So this is plus I3 and this is minus I3, so it get cancelled. So the current which is flowing through this section, that is CE section, is I1 plus I2. So it is marked here and it is flowing like this. So consider the loop AB. This loop is considering first ABDA. That is a loop which is considering first, and applying KVL. Then we get this. We are going in this direction, ABDA. So the first voltage drop is minus 1 I1. So here the current flowing in this direction, and we are also going to analyze the circuit in the same direction. So this value is minus I1, and next one is we are going in this direction B to D, and the current is also in the same direction. So minus 5 into I3 is the voltage drop occurs here. And in the third section, that is, we are going from D to A, but the current is coming in the opposite direction, so this value is positive. So plus 4 I2 is equal to 0. That is the first equation. Minus 1 I1 minus 5 I3 plus 4 I2 is equal to 0. Or we can write the same equation like I1 plus 5 I3 minus 4 I2 is equal to 0. That is, we are simply interchanging the sign of the values. So mark it as equation number 1. And in the same way, we can write the loop equation for the second and third loop by applying the KVL. The second loop is BCDB. That is, here we are considering this section BCDB. On the similar way, we can write the equation by applying the KVL, and we get the equation like 2I1 minus 10I3 minus 3I2 is equal to 0. Mark it as equation number 2. And the third loop is FABC. That is FABCEF. This is the third loop, FABCEF. And the loop equation is minus I1 into 1 minus 2 into I1 minus I3 minus 1 into I1 plus I2 plus 4 is equal to 0. And on rearranging this equation, we get 4I1 minus 2I3 plus I2 is equal to 4. Mark it as equation number 3. On solving these three equations, we get the value of I3 as 20 divided by 230, that is equal to 0.087 ampere. So the question is, what is the value of current which is flowing through the galvanometer, that is galvanometer resistance, or here it is 5 ohm resistance. What is the value of current which is flowing through this 5 ohm resistor? Here the current which is flowing through this 5 ohm resistor is I3. So the value of I3 by solving the equation we get as I3 is equal to 0.087 ampere. And next question is, what is the resistance between the terminals A and C? That is the second part of the question. And here the current which is flowing through the 5 ohm resistor I3 is equal to 0.087, which is a positive value. So the direction of flow of current is true. That is, the current is flowing from B to D, since the value of this current is positive. And for finding the second section of the question, we know the value of I3, and by substituting the value of I3 we can get the value of I2, and substituting the value of I3 we get I2 is equal to 0.348, and apply this value in equation number 2, we get the value of I1, and I1 is equal to 0.957 ampere. And the current which is applied by the battery, from the figure we get I is equal to I1 plus I2. From the figure we can get that the current which is supplied by this battery is I, that is equal to I1 plus I2. So we know the value of I1 and I2, substitute those values, then we get the value of I. I is equal to 0.957 plus 0.348 is equal to 1.305 ampere. So the next step is that we have to find out the potential difference between A and C. So the potential difference between A and C is equal to EMF of battery minus the drop in battery. We know the EMF of the battery is 4 volt. 4 minus the drop in battery, that is we know the current which is flowing through that source is 1.305, and the resistance of that section is 1 ampere. So this drop in battery is equal to 1.305 into 1. So the entire equation becomes 4 minus 1.305 into 1 is equal to 2.695 volt. So this is the potential difference between A and C. Therefore, the resistance between A and C is equal to the potential difference between A and C divided by the battery current. So potential difference across A and C is 2.695 divided by the battery current, that is this I. I is equal to 1.305. On substituting these two values, we get the resistance between A and C as 2.065 ohm. So we get the resistance which is offered between the terminals A and C as 2.065 ohm. So that is the answer. Okay, consider the second question. Determine the current in 4 ohm resistance of the circuit which is shown in figure. Here we have to find out what is the value of current which is flowing through this 4 ohm resistor. So the circuit consists a 2 ohm resistor here, 2 ohm here, and 10 volt battery, 6 ampere current source, 1 ampere resistance, and 10 ohm resistance, and here also a voltage source of 24 volt. So these are the components of the circuit. So first of all, we have to mark the currents which is flowing through the various branches of the circuit by using the KCL, Kirchoff's current law. By using the KCL or Kirchoff's current law, we have to mark the currents which is flowing through the circuit at various branches of the circuit. Since there are 3 unknown quantities, here we are marking the current which is flowing through the circuit as one is I1, and second quantity is I2, and third quantity is I3. That is, we are considering 3 loops in this circuit, so there are 3 unknown currents. And then after marking the unknown currents of the circuit, we have to apply the KVL, Kirchoff's voltage law, to analyze the circuit. So we can redraw the circuit like this one. That is the same circuit. We are just rearranging the positions of the 6 ampere current source like this. So 2 ohm resistor and 6 ampere current source is placing here, and 10 ohm resistor, 2 ohm, 3 ohm and 10 volt battery, and 4 ohm resistance and a 24 volt battery. So the same circuit, we can just redraw the circuit like this, and then mark the currents. That is, the current which is flowing through this 4 ohm resistor is taken as I1, and that I1 is flowing through this 24 volt battery, and it is coming to this point B. And the current which is flowing through the next section, that is BH section is here it is I2, and from this node a current 6 ampere current is flowing in upper direction. So the current which is flowing the other section, that is from here to here, it is I2 minus 6 ampere, which is flowing through this section, that is through this 1 ohm resistor. And here the current which is flowing in this direction is, here it is I1 is entering at the point B, and I2 is leaving from this junction. So the current which is flowing through this 2 ohm resistor is I1 minus I2. And at point C we get I1 minus I2, and the same current is flowing here also. And at this point I1 minus I2 and the effect of 6 ampere is also coming here. So I1 minus I2 plus 6 ampere is flowing through this section. And at point D, the current which is flowing through this 10 ohm resistance is I3. So the current is coming to this junction D, and the current which is coming in this from this section is I1 minus I2 plus 6. And we can add the value of I3 also here. So the current which is flowing through the next section, that is 2 ohm section, 2 ohm resistance section, is I1 minus I2 plus 6 plus this I3. So the current which is flowing through this 2 ohm resistance is I1 minus I2 plus 6 plus I3, and which is flowing through the 10 volt battery, and it is entering at this point F. And here from the point H, what is the current which is flowing through this 3 ohm resistance? Here it is I2 minus 6, and from this section one more current is leaving from this section H, from the point H. So the current which is flowing through this 3 ohm resistance is I2 minus 6 minus I3, which is flowing through this 3 ohm resistance. So the current which is entering at the point F is I2 minus 6 minus I3. So by combining these two currents, we get the final current as I1, and which is flowing through this 4 ohm resistance. Okay, these are the currents which is flowing through the various branches of the circuit. So the difference is that here we are considering a current source also. In the previous problems we are considering only voltage sources, and here we are considering the current source also. So after marking the currents which is flowing through the various branches of the circuit, we can apply the Kirchoff's voltage law. So by applying this Kirchoff's voltage law, we can get the first loop equation for the loop BCDHB. BCDHB. This is BCDHB. For this loop, we get the equation like 2I1 minus 3I2 minus 10I3 is equal to minus 6. Mark it as equation number 1. And for the second loop, that is DEFHD. DEFHD. This is the second loop. For the second loop, we can follow the same procedure, and we get the equations like 2I1 minus 5I2 plus 15I3 is equal to minus 40. This is the second equation. And the third loop